So LeetCode 1492, the kth factor of n. In this problem, you're given two positive integers and you need to return the kth factor in the list of all factors of n. And if n has less than k factors, just return -1. So the trivial way of doing this is just looping through all of the numbers from 1 to 12, keeping some sort of counter of how many factors you've seen so far, and then returning the current number when your counter reaches k, right? So that's the easy way. However, that has a time complexity of O of n, so you want to do this in the optimal way, which is O of square root of n. And to do that, you need to observe that for every divisor that you find, you actually get two divisors. So you get like a main divisor, for example, where we have n equal 12, and you see that 2 is a factor of 12. You actually find two divisors, 2 and 6. Because 12 divided by 2 needs to be an integer, because 2 is a factor of n, so you need to have an integer. The quotient needs to be an integer, and that integer is your secondary, is like your alternative divisor, right? So for any time you find a factor, you're actually getting two factors. Unless like the number is a square, like for example, if n is 9 and you get the factor 3, then 9 divided by 3 is 3 itself. So you're not finding a new factor, but you're still getting like a second one. It's just that it's the same as the first one. Okay, so what we're going to do is we're going to loop through all of the numbers from 1 to the square root of n, right? And we're going to basically do the same thing as the original solution. So we keep a counter of the current factor count, so the number of factors that we've found so far. And yeah, you go from 1 to the square root of n, and we just floor it. Like this is a easy way, fast way of flooring a number in JavaScript. And if your current number has a n modulo I is 0, meaning that I is a factor of n, then you increment your current factor count by 1. And if your current factor count reaches k, then you return your current divisor. So that's easy. That's like the trivial way. It's just that instead of going all the way up to n, you go up to square root. And then you need a second loop that goes back down from square root to 1, right? And here, instead of looking at the main factor, which is I, we're going to have to look at the secondary factor, okay? So first of all, we want the guarantee that I is a factor of n. So if I is not a factor of n, then we continue, right? So from now on, here in this loop, we know that I is a factor of n. And now we want to take the secondary factor, like the alternative divisor. So the paired divisor. So for example, if n is 12 and I is currently 2, your pair divisor is going to be 6 in that example. And now you want to make sure that pair divisor is actually different from I itself. So it's not just like a square. So it's not like 9 divided by 3, which is still 3. So if you have an actual different divisor, so it's a new one, then you want to increment your current factor count, right? So if it's different from I, you increment your current factor count. And if your current factor count reaches k, then you want to return the new divisor, which is not I, it's pair divisor, right? That's the new divisor that you found, okay? And if you never return something, then it means that you have less than k factors, and so you can return -1. So I'll submit the solution to show that it works, and the time complexity is O of square root of n, and yeah, the space complexity is just constant because you don't have any array or list or any data structures. So that's it from me. Thank you for watching, and bye.